Hello there, welcome to Maths is Not a Mystery again. We're going to look at sequences today. Sequences are basically number patterns, and the point about a sequence is that it's predictable. So if you have a random number pattern, like 2, 9, 3, 242, that's not a sequence, nor is it really a pattern, because you can't predict what's going to come next. A sequence is predictable. Now, some sequences are really easy to predict, 2, 4, 6, 8, 10. Some sequences are much harder to predict. They're still sequences. We're going to look at relatively straightforward sequences in this video. There is a more complicated video about quadratic sequences, which are much harder to follow, but we're not going to cover those in this video. All right. First point about sequences is that really to be able to decide whether there is a pattern available or not, you do need three numbers. If you had, for example, just 2 and 4, you could say that the sequence was 2, 4, 6, 8, 10. That's a sequence and it's fine. You could also say it's 2, which you double to make 4. You could then double it to make 8, and then double it to make 16. That's also a sequence, isn't it? And because you've only got two numbers there to work with, you can't really decide what the sequence is. You do need three numbers at least. Then you can start to figure out what the sequence is. If this said 2, 4, 6, you'd be pretty much clear that it's 2, 4, 6, 8. If it said 2, 4, 8, you'd be pretty much clear that you're doubling it each time. Okay, so very important that you have three numbers. Don't try and make an assumption if there's only two numbers. Each number in a sequence is called a term. And on the easiest level of sequences, all you've got to do is you've got to find out what they call the term-to-term rule. And that means how do you get from one term to the next? This sequence here, 3, 7, 11, 15, you've got to think about the term-to-term rule. And in order to do that, you need to consider not the actual numbers of the terms, but the gaps between them. Okay, the gap between 3 and 7, the gap between 7 and 11. And if you look at it, to get from 3 to 7, you're going to add 4. Sorry, that didn't come out terribly well, the add, did it? There you go, looks a bit better. To get from 7 to 11, you're going to add 4. And to get from 11 to 15, you're going to add 4. So the term-to-term rule is add 4. And if the question said to you, continue the next three terms of the sequence, well, you'd add 4 again. 15 plus 4 is 19. And then 23. And then 27. Okay? The one below here, to get from 8 to 5, you subtract 3. To get from 5 to 2, you subtract 3. To get from 2 to minus 1, you subtract 3. So the term-to-term rule is subtract 3. And if you're asked to continue it, you keep on subtracting 3. So minus 4, minus 7, and so on. Your sequences could also be diagrams or shapes. Be careful with these, because that's 1 square, 2 squares and 3 squares, but look at the number of lines that are required. On the first one there's 4 lines. On the second one there's actually 7 lines. You've got your first 4 plus another 3 lines, because this middle line here is shared between both squares, so that's actually 7 lines. This one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's going up again in threes, isn't it? The term-to-term rule is add 3, and if you were to be asked to draw the next shape along, yes, it would be 4 squares, but you need to make sure it contained 13 lines by just adding an extra 3 lines to the shape, not an extra 4 by putting an entire square there. That's the simple area of sequences then, just basically finding a term-to-term rule. What does it go up by or what does it go down by, and carrying on doing the same thing. Most of the sequence questions, however, won't be that. There'll be something called the nth term. Now the nth term, that word nth, N stands for number, and what it means is that we could ask you to say, here's a sequence 4, 7, 10, 13. That's the first term, that's the second term, that's the third term. What would the 25th term be? Now, you don't want to really be working your way all the way through the sequence, particularly if you're asked a big number, what is the 175th term? So what you need to do is you need to find a shortcut, because maths is all about finding shortcuts. What is the rule? Well, we know that the rule is something to do with adding 3, because that sequence goes up in 3s every time. So what we're going to do is we're going to start with the sequence by writing 3n. Now 3n is a very posh mathematical or algebraic way of saying the 3 times table. 3 times any number. 3 times any number will be on the 3 times table. But this isn't the 3 times table, is it? This sequence here starts at 4. 4 is one more than the 3 times table. So the sequence is called 3n plus 1. It's the 3 times table, but every time it's one more. 3 times table is 3, 6, 9, 12. The numbers here are 4, which is one more than 3, 7, which is one more than 6, 10, which is one more than 9, 13, one more than 12. It's always the numbers on the 3 times table plus 1. And that's how you work out the nth term. Then you find the gap between the numbers, what it goes up in. It goes up in 3s, so it's related to the 3 times table. But if it doesn't actually start at 3, like the 3 times table does, then it's plus 1, or plus 2 if it began at 5. This one down here, 5, 11, 17, 23. Well, again, let's look at it. It goes up in what? How do you get from 5 to 11? You add 6. How do you get from 11 to 17? You add 6, add 6. It's something to do with the 6 times table, so it's going to start off as 6n. What does the 6 times table start on? Of course, it starts on 6. Well, this one here starts on 5. It's 1 less. 6n minus 1. And then just check it through your 6 times table. Is it always 1 less? 6, 12, 18, 24. Yes, it is. Every time it's 1 less than your 6 times table. So 6n means your 6 times table. Subtract 1. It's your 6 times table minus 1 every time. Okay, so to find the nth term, that's what you do. Find the gap between the numbers. Whatever that gap is, 3, 6, 9, whatever it is, that's the times table you're dealing with, and that's the n, 3n, 6n, 12n, whatever it is. And then your starting point is compared to where it would be on the real times table. So 3 times table starts at 3, this is plus 1. 6 times table starts at 6, this is minus 1. Now you could be asked a question the other way round. Rather than find the nth term, you could be asked, write down the first 4 terms of this 4n plus 2. What do you do there? Where do you know how to start? Well, let's take a look. Pretend that n isn't there. And if the n wasn't there, this would just say 4 plus 2. And 4 plus 2 is 6, and that is where you start. And this is the 4 times table plus 2. So it's going up in 4s, but it's always going to be 2 more than your 4 times table. So basically, keep on adding 4 now. 6, 10, 14, 18. Is it your 4 times table plus 2? Think about your 4 times table. 4, 8, 12, 16. Every time the numbers in this sequence are 2 more than your 4 times table. So it's correct. 5n minus 3. Okay, so pretend the n isn't there. All you would have there would be 5 minus 3. So your starting point is 2. 5 minus 3 is 2. It's all related to your 5 times table. That's what the 5n is about. So it's going to go up in 5s. So add on 5, which makes 7. add on another 5, it's 12, add another 5, makes 17. And that's how you do an nth term in the other direction. They give you the nth term, you work out the sequence. Now finally, in this section, you could be asked a sort of logic problem. Why can't 29 be a term in the sequence 3n plus 4? So 3n plus 4, they're not asking you to work out 3n plus 4. They're not asking you to draw the entire sequence out. They're asking you, well, they're already telling you that 29 isn't in that sequence. Prove it, basically. Well, let's have a think. 3n plus 4 means take any number, any whole number, times it by 3 and add 4. So if it's times it by 3 and then add 4, we're going to do it the other way round. Instead of that, we're going to do it back to front. And what would you do in reverse? You would take away 4 and then you would divide by 3. Go completely backwards through the entire little section of it. So start from 29. First of all, you would take away 4, and that would leave you with 25. And then 25 divided by 3. Well, I'm not even going to go any further than that, because 25 divided by 3 is not a whole number. 25 isn't exactly divisible by 3, and that's why 29 can't be a term of 3n plus 4, because it's not leaving us with a whole number there. Okay, so you don't actually even have to write the answer down. It's just no. It can't be. It's not a whole number, and therefore it's not on the sequence. Okay, so I hope that makes some sense. If you were looking for things to do with quadratic sequences and finding the nth term of quadratic sequences and double differentials and all that kind of stuff, you're going to need to look at sequences 2 instead of this video, which has been sequences 1. But I hope this has been enjoyable, and I hope you've understood what's been going on there. Thank you for watching, and we'll see you again soon. Bye bye.